exponents are those little bitty numbers you see floating next to the big ones.
We know x plus x equals 2x.
So, x squared plus x squared equals 2x squared. Because they're like terms, we can add them together to equal 2x squared.
However, we cannot add x squared with x.
Because x and x squared are not like terms, we cannot add them together. So x plus x squared is already simplified.
We can add together 2x and 3x to get 5x.
Because x and x are like terms, we can add together their coefficients 2 and 3. 2 plus 3 equals 5. So 2x plus 3x equals 5x. To show this, we have these apples, each representing x squared. 1 apple and 2 apples makes 3 apples. So x squared plus 2x squared equals 3x squared. X squared and x are very different, just like an apple and, say, this potato, so we cannot add them together.
Therefore, x squared plus x is in simplest form. Similarly, 2x squared minus x squared equals x squared. We know this by looking at the coefficients. 2 minus 1 equals 1.
If we have 2 apples and we take away 1, we're left with 1 apple.
We know that 2 cubed equals 2 times 2 times 2, which equals 8. So, n cubed equals n times n times n.
But what if we want to multiply 2 terms with exponents? To multiply them together, add their exponents. So, a to the third times a to the second equals a to the 3 plus 2. 3 plus 2 equals 5, so the answer is a to the 5th.
b to the third times b to the 5th is equal to b to the 3 plus 5, which equals b to the 8th.
Also, we can multiply monomials with coefficients by breaking up the monomial. So the coefficients are multiplied together and the variables are multiplied together. In this example, we have 6 times m to the third times 2 times m to the 7th. Thanks to commutative property, we can regroup these to be 6 times 2 and m to the third times m to the 7th. Our final answer is 12 m to the 10th.
To find the power of a power like this, multiply the exponents.
N to the third to the second is equal to n to the 3 times 2. Your final answer is n to the 6th. We can show this because n to the third to the second is equal to n to the third times n to the third. And we know when we multiply variables with exponents, we add the exponents. So the answer is n to the 6th. When we divide terms of exponents, we subtract the smaller exponent from the larger exponents of like terms. In this example, because 2 is smaller than the 5, we can subtract 2 from both the top and the bottom. And because 1 is smaller than 4, we can subtract 1 from the top and the bottom. We're then left with t to the third, u to the third, over 1.
We use scientific notation to express large numbers, like this one.
To express scientific notation, start by moving the decimal point over until it's to the right of the first non-zero digit. Then count the number of spaces you moved it over. We then express our necessary digits, and we multiply it by 10 times the power of the spaces you moved. If we move the decimal to the left, we express it to a positive exponent. If it's to the right, it's to a negative exponent.
Thanks to the commutative property, we can make this say 3.5 times 7 times 10 to the negative third times 10 to the fifth.
We can then express this whole thing as a scientific notation by multiplying 3.5 by 7 to get 24.5, and 10 to the negative third and 10 to the fifth to get 10 to the second. Our answer is 24.5 times 10 to the second.
If we have 24 times 10 to the fifth over 8 times 10 to the third, you can divide it into 24 over 8 and 10 to the fifth over 10 to the third.
24 divided by 8 is 3 times 10 to the 5 minus 3. Our final answer is 3 times 10 to the second. A polynomial is a monomial or the sum of monomials. To get each one is called a term. Mono meaning single and polynomial meaning many. We can start identifying polynomials by looking at the number of terms it has. Each number of terms has a specific name that goes with it. If it has 2 terms, it's called a binomial.
If it has 3 terms, it's called a trinomial.
If it has 4 plus terms, we call it a polynomial.
Polynomials are also identified by the largest exponent. Each degree has a specific name. If there is no exponent, it's constant.
So the first power is linear.
The second power is quadratic.
So the third power is cubic.
To the fourth power is quartic.
To the fifth power is quintic. Anything more is considered to the 6th degree, 7th degree, 8th degree, etc.
My density of a polynomial is the degree followed by the number of terms.
If we look at this example, we can see that the highest exponent is a 3, so it's cubic. And because there's 3 terms, it's a trinomial, so it's a cubic trinomial. In the standard form of a polynomial, the exponents are in order from greatest to least, left to right. The first coefficient is called the leading coefficient.
This polynomial is in standard form. In this example, 4 is the leading coefficient.